All right. So if you're looking at the data, which talks about the temperature variation, right, from January to December, and then later you have to figure it out the periodic behavior modeled by a sine curve, right, sine function. But I guess that you still remember. I wish that they can use the consistent notation, but the overall prefactor stands for the amplitude, right? That B tells you something about a period, right? And this is the vertical shift, right? And the C tells you about the phase shift. So among those, key features like amplitudes, period, phase shift, vertical shift, which one would you start to investigate first? Amplitude, right? So that's, probably the easiest one. So now you do get to, eliminate, right? Just using amplitude, because you see that 3 of them has the same amplitude, right? The last one's different. So, I mean, hopefully you realize that most likely D is not going to be right. Because think about if amplitude is the easiest one you can look at, they don't want everyone to simply just go with amplitude and pick the D, right? So, but, like I said, check the D, but you see that the amplitude is going to work out as 22.5. But how do we see it? Now, again, take a close look at the data and see if there's a way for you to convince yourself that the amplitude needs to be around 20 something, 22.5. Oh, yeah, Max, you have some thoughts?
So, like, yeah, like the number.
Good. Yeah, that's actually what we talked about, right? But that was almost a month ago. So let me show you the trend of the graph so that you see, why something just going between the lowest and the highest, right? So starting from January, right? So temperature is kind of low, right? Maybe it looks like a minimum, right? So start to rise, and it's gonna peak at around July, right? And then start to fall back down, right? And hitting maybe at the lowest temperature somewhere around December, right? Not very accurate, but at least that it makes sense, right? So Max is talking about finding the lowest and the highest, right? And, take the midpoint, right? And see how many units up above the midpoint, right? How many units down to get the amplitude, right? You can do that. Or if you just want to find the difference between the lowest and the highest temperature, in this case will be different between 19 degrees, right, and 65. So that would be what, 65 minus 19. So that's 46, right? But you realize that 46 is not the amplitude. It's twice the amplitude. You divide by 2, yes. You later on divide by 2, right? The same way, you're going to get the same thing. And it's exactly 20 something, no, 23, right? It's close enough, right? You're definitely going to rule out letter D, right? Since 25.7 is a bit way off. So that's the amplitude. What's the next thing you're going to look at after the amplitude? Area, right? So that's actually a bit harder than, most people thought, right? So, I mean, how you guys will be trying to get at least like a rough estimate of the period? The slope, okay, see like how fast it goes up and down. So what does period means? If I say the temperature throughout a year is periodic. Right. So if you start from like a very low temperature, do you see that 19 is actually one of the lowest, not one of them, it's the lowest temperature, right? So you kind of hope that you can trace the trend and go up and come back down to the lowest temperature again, right? Which unfortunately is going to be, maybe a bit beyond December, right? Maybe back in January, right? But does it make sense that it seems that the period is only 12 months? Because this is roughly how long it's going to take for the lowest temperature to occur, right, to reappear, right? But then if you think about for one more second, isn't that the case that the temperature throughout a year is going to be periodic and appears one year, right? Because that's why we have year after year, right? That's why you're not expecting, say, during our spring break, and the temperature is like 30 degrees, right? Because it didn't happen historically, right? Maybe very rare, right? Maybe something seriously wrong. So that's why if you want to do some like a guess, I'll say it's 12 months. So now if the period is 12 months, how would you find out that b? The formula is 2 pi over the b, right? Or in this case, they're using lowercase b for some reason. You're solving for the b, right? Make sure you do the algebra correctly. 2 pi divided by 12, right? So it'll be roughly, I'll tell you how much that is. 2 times 3.14. 0.5, okay, thank you. Again, close enough to figure it out, right? So A must be wrong, right? Because, the period is way off. So now you're down to B and a C. And the vertical shift are the same, right? That means don't even bother, right? So the difference between the B and C is the phase shift, right? So now how would you do that? How would I find the exact phase shift? So that's actually the hardest part, if you remember back in February 2nd or 3rd. So I'll say that, you know that the sine function is going to peak at pi over 2, right? Remember that the maximum, if you remember the sine curve go up and down, right? It's going to reach the first peak at pi over 2. But how come that the temperature peaks at 7? Well, of course, there's no way you can tell, right, how the 7 is magically worked out, right, in such a way that, it's related to, where the sine has to peak. But if you look close at, let's say, letter C, do you see that when the temperature is at the peak, say, when x equals to 7, right, the temperature is 65, I mean, I should expect if I take 7, plug it in, I should be expecting what temperature? 65. So you could have just shuffled 7 into the x and figured out if that will give you 65 or letter B, right? Does it make sense? It's a multiple choice, right? Why would you bother with the hard work to find out the phase shift? But then you say, wait a second, if I could use the calculator, why am I doing these? Can I just take any random number of x? The x stands for the month, right? Take x to be 1. Plug into all 4 to see which one returns 19. You're going to get the answer anyway, right? Does it make sense? So that's a multiple choice, right? But if it's really FRQ, I'm sorry that you do have to work these out, right? And I mean, hopefully that, you get these guys right. So you get, 3 out of 5 already, 4 out of 5. One more thing I'm looking for is the phase shift, right? So now let's do it in the right way. So how do I get the phase shift worked out? So still I will pick, x equals to 7, right? So I'll evaluate the function, which is 22.5. I'm assuming that's, the shape is a times sine bx minus c plus the d, right? So that will be, what is it? Sine, right, of 0.5, right, times x plus, actually minus the c, right? So we're trying to figure out what the c is, plus and I still have the D, right? So now it turns out that, if you do have multiple choices, you don't have to worry about a D, but except for Q, you have to figure out a D before you can do something about a C, right? But B is actually not that bad. So it has been vertically shifted, right? But you know that the graph's supposed to go up and down about the 0, right? If it wasn't shifted. But where's the midpoint? So it's so how much is it? Well, I have to. Did you just add up the 65 and 19 divided by 2? So from 19 up to, by adding 23 to the 19, is that what you did? Because I'm trying to find out where the midpoint is. So if you see that, if it's as high as 65, as low as 19, where's the midpoint of the temperature? You add up 65 and 19, divide by 2, right? It's 42. That'll be somewhere in the middle, right? So that means that you'll be shifting the graph from 0 up to somewhere like 42. But of course, that's not very accurate, right? Because you get 40 something, right? So that's why this is a multiple choice. But let's say if I do have the D figured out already, let's go with maybe 42. I know that's something off, but I think that will be good enough for us to figure out what the C is. So I want to have the peak temperature to be at 65, right? So you're going to solve for the C. I hope that you're going to do some algebra like you did before, right? Isolate the sine piece, right? By subtracting 42 from both sides. So we're looking at 23, right? And divide out, oh, you know what? That's a bad way of doing it. And you know why? Since we have errors in the calculation. And the reason why it is, if you do the division, you realize that the sine is greater than 1. And that's because we didn't get to exactly how much the vertical shift is. If you remember back in February 3rd, we say that if this is going to peak at x equal to 7, right? It will only happen when the sine function reaches the maximum, right? Which must be at 1. And how do you think the sine is going to reach the maximum? The angle here, right, which is the input for the sine, must be exactly pi over 2, right? Therefore, you have 0.5 x minus c, right, equals to pi over 2. Remember that you're going to feed the 7 to the x, right? So it will be 0.5 times not 0.7. 7 minus c goes to pi over 2, right? And you're going to get 7 over minus c to be pi over 2 divided out of 0.5, right? You're going to work out what the c is. All right, so let me see how much that is. Pi over 2, 1.75 divided by 0.5. All right, so about 3.86, okay? And it should be very close to one of those, or at least that closer to letter C, right, than it is to the letter B, right? The phase shift is not 1 point something, right? It's going to be 3 point something. And again, the reason why I'm off is that the 0.5 is just a rough estimate, right? If you really work it out, I think that's going to be 0.5 something. But like I said, so if this is a multiple choice, I hope that it should work out, a lot faster, right? Because again, if you're looking at the amplitude and a period, that should be good enough, right? If you really want to use, the calculator to find out the phase shift, you could do that, but don't try the hard way. since you only have to pick between B and C, right? Pick a number, plug it in to see if 3.2 or 1.6 for the phase shift is going to get you the right, temperature, right? When, you evaluate it, at the correct X, right? Yeah. So, but like I said, since I promised you guys that there will be, word problems, and most likely it's about the 5.8. This is not 5.8. But technically speaking, since I only do the draft, right? The department need to, and they could, revise it, and that seems a good problem, but it's not very easy to do it, perfectly in a test. All right. Anyway, so at least I have it recorded, then I'll share with the other two periods. All right. So now let's address some graphing issues. And Juwan reminded me, I need to show you guys how to label the graph appropriately. So if you have to graph something by hand, so will be the best way to do that instead of making a graph, a little bit too messy, or and you're getting overwhelmed when you have to do multiple graphs, right? So if you take a look at letter B, sorry, not letter B, number 8, can you imagine what the graph should look like? Amplitude is 3, right? Then what about the negative sign? Flipping it, right? But I guess the hard part is, what about the 1/3? Stretching, right? So I think that it's not very likely you guys gonna mess up the vertical transformation, right? As long as you don't forget it, it's gonna be stretched and flipped. It is the horizontal one that sometimes people thought that, 1/3 of X, is that shrinking a graph? But the horizontal thing are, non-intuitive. But I'll say that, can you imagine how wide the graph is? Or let's say, what about the period of the new graph if it's supposed to be stretched, right, by 3 times? Yes.
Would the period 6 times?
Yes. If you work it out, it'll be 2 pi over the b, right? If you realize that it's a stretching, so it'll be 6 pi, right? Yeah, this is a bit too thick. So now let me graph a sine curve, and I labeled it as 0, right? Pi, 2 pi, 1, and -1, right? And I labeled this as sine of x. So now you're gonna have to show me maybe 3 more graphs, right, on the same grid, so that you can convince me that you did the vertical stretch and flip, and also the horizontal flip. Not the horizontal flip, horizontal stretch, right? But it's very hard to graph a function that has the period to be 6 pi if you already fixed the scale, right, to be from 0 to 2 pi within that space, right? Now, if you want to imagine what the graph looks like, it will be a super wide, right, graph. So this is not a good idea. What you could do is, since you already know what the sine looks like, and you know that the period has to be 6 pi, right? Why would I label the scale like that? Now, if I were to graph sine of 1/3 of x, how much should I label this point? It has to be the period, right? 6 pi. Now, this has to be half of the 6 pi, right? Be 3 pi. Now, this is, half of 3 pi with 3 pi over 2, right? What about this one? not half of 6 pi. It's the midpoint of 3 pi and a 6 pi. So what you do is you add up 3 pi and a 6 pi, divide by 2. So it would be 9 pi over 2. Right? If you're not sure about these two marks, right, they're a little bit trickier than the 3 pi and the 6 pi, don't label them. Right? What if you got wrong? But at least that you should be able to label the 6 pi and the 3 pi, right? So that's the graph once you stretch it. Now, can I also graph right away to show the vertical stretch? If I'm kind of lazy, I don't want to do a new graph. Yeah, so I can cheat a little bit by changing the label, right? Because we know that the amplitude is supposed to be 1 if it's regular sine, but you stretch it by 3 times, it will be 3 and -3, right? Does it make sense? So you see that it's still a clean graph, right? That shows up all the features except for that negative, right, sign, which is the vertical flip, right? So then you can easily do that by showing me at least another graph that shows the graph is vertically flipped. Okay, so this one is -3 sine of 1/3 of x. Okay, so now if you still want to see that how those labels going to work out as fast as you can, the rule is very simple. Find the period, right? Take a half, take another half if you want, right? Because those two are the midpoints. But I guess that if you find the period and the midpoint, that should be good enough to tell me, or even if you don't have to graph by hand, the way you're looking at this graph is the same as the way you'd be looking at those options, right? Don't you think that you should be looking for a graph that goes as wide as 0 to 6 pi, right? And the midpoint when the graph comes down has to be at 3 pi. Those skills works out just fine. All right, so now let's use that trick to graph let's say number 9, right? And also let's try to act a bit smarter, before we know all those techniques, right? And also we're trying to cheat a little bit by using the scales in a smart way. So first off, what do we expect from a graph like that, right? What has been changed? Let's say when it comes to period, right? Or the phase shift, right? Amplitude. Amplitude is 2, right? What about the period? It's a 2 in front of x. So you thought that's going to make the graph wider? No, it will be narrower, right? So it'll be squeezed by 2 times. So the period is going to be pi, right? And then later, I'm going to take up the phase shift. So the sine graph looks like this, right? But instead of going between 1 and 1, I'll go between 2 and -2, since I have the amplitude. Instead of labeling as 2 pi, I'll be doing pi, right? And pi over 2 to show that the graph has been squeezed. Now, the hard part is, what about the phase shift? So I know that, since you're adding the pi, that means it's shifting to the left. By how many units? Half the pi. How do you guys figure it out? Okay, so I guess that it sounds like the phase shift formula, you guys happen to remember. So that's C over B, right? Therefore, you have pi, which is the C value, divided by the B, right? So that's pi over 2. Now, if it's plus or minus, it doesn't matter to the units. It only matters to the direction, right? So I'll be shifting the graph to the left by pi over 2. This is how big the pi over 2 is, right? So now what I'm going to do is I'll try to grab maybe a reference point, say the starting point, right? So I'll pull it to the left to negative pi over 2, right? So now the graph's supposed to come down at pi over 2, right? But now it's going to come down at 0, right? And go down and up. So now the blue curve is 2 times sine of 2x plus pi. Right? Does it make sense? Now, I'm saying that this is something that you only have to do if you do it by hand. But I hope that you can tell by looking at the period, right, and amplitude right away to figure it out. Let's say it goes between 2 and 2, right? Look at this little d, right? You see that? It's the correct amplitude, right? And the width is only half of the original one. And the reason why it's probably upside down is we have we have a horizontal shift. Okay, but at least that's definitely not going to be A, right? The amplitude is wrong, and also C. All right. All right, so I guess that the remaining 4 functions is going to be a lot worse than the sine and cosine. But hopefully, when it gets to those functions, so I don't want you guys to graph as detailed as you normally do for sine and cosine. And also, it's pretty much like if you know what the graph of tangent, cotangent, secant, and cosecant look like, especially if you know what the tangent or cotangent look like, it should be relatively easy to graph those variation of, oh, sorry, that's not the problem I'm referring to, those guys. But I realized over the past 2 days, when people came to me and they had either some issues with homework or they asked me about, graphing the tangent cotangent function, I see that they somehow struggle a little bit of identifying which graph is the tangent or cotangent, right? Because they look so similar. Of course, sine and cosine are also similar, but tangent a little bit worse because they're not like closed graph, right? They goes all the way to the positive infinity, negative infinity. So one of the students on the first period said, if you can imagine, compared to the cotangent, tangent should be a nicer version. It's a graph. It's a function that you will normally expect for a nice graph that usually goes from the bottom left rising to the top right, right? Not to mention, the shape of a line that comes to your mind, right away will be a line that rises, right? And the tangent is a line, right? Tangent line. And it turns out that if you're going to go to, calculus anytime soon, you know that they'll be dealing with the tangent for many weeks, right? So long story short, the tangent graph should be the one that's more intuitive, right? Nicer when it comes to the trend. It starts from the bottom left, rise it to the top right, okay? Now, cotangent is not only flipping the tangent graph, it's also shifting to the left, okay? But like I said, if you know what they look like, it shouldn't be too hard to graph, even just the tangent graph with a phase shift, right? But please make sure that you include the VA when you graph it. So tangent will be somewhere in between negative pi over 2, right? And a pi over 2, right? That's the 2 VAs. So tangent is going to look like this. But if you're going to shift it to the left, right? Since you're adding the pi over 2, shifting to the left by pi over 2, you are shifting also the VAs. So this VA is going to go to negative pi, right? Since you're moving everything to the left by pi over 2. That VA started at pi over 2 is going to be pushed back to 0. And then the x-intercept is going to go to the left by pi over 2, right? That's why This is what the new graph looks like, right? That's tangent, right? X plus I over 2. Okay? That's the tangent graph, right? It's pretty much you know what the tangent looks like, then just shift it. All right, so let's see about a cotangent graph. So the cotangent will be in between 0 and pi, right? Those are two VAs. And it's going to go from top left going down. That's actually intersecting pi over 2. Okay. So now I need to shift it to the left, right, by pi over 2. And that's how much the pi over 2 is, right? So we push those two VAs back by that small amount, right? So the 0 will go to negative pi over 2, right? And the pi, the VA pi will be pushed back to pi over 2, right? And we're looking at a graph passing through instead of pi over 2, but 0, right? So this blue curve stands for cotangent x plus pi over 2, right? And that negative sign will make it flip vertically, right? That means I could have done the negative cotangent, right, by drawing the other way around. But now if you want to show me the graph that does get stretched by 3 times vertically, how will a new graph look like if you have to stretch it based on the one I just draw, right? But make it like somehow stretched vertically by 3 times. Will it get narrower, wider? Can you imagine that? If I'm holding a point down below here, right, and a point up there, and I stretch it vertically, it gets narrow, right? But the VA stays at the same place, right? It doesn't mess with the VA. So the graph's going to look a lot skinner, right? So I'll do a graph like this. Oops. Okay. So it might not be that easy to see if you go through those options, right? Because sometimes how would you know that this graph is skinner or fatter than what it's supposed to? But if you hand graph it, hope that there will be a way for you to show me that this is the graph that has the vertical stretch. Okay. All right. So now we're left with only secant and cosecant. But they're actually not worse than the tangent and cotangent. If you're confident at this point that you can graph the sine and cosine plus their variations, because if you can do that, the graph of the secant and cosecant are just one more step. All right, so let's take a look at 23. So what I want you to do is graph the reference function for secant or cosecant. But by reference function, I mean, it's just the reciprocal of secant or cosecant. So I believe that the reference function is going to be cosine, right? So cosine 2x minus pi over 4 plus 2. So this is like, pretend that you didn't see the secant graph, right? Go ahead and find the graph of the cosine, then do something, to get the shape of the secant. Now, oh, that's a 4. So pi over 4 right, so now if we want to quickly graph cosine 2x minus pi over 4, I'll do a cosine graph, but let me make sure that it's as perfect as it can be, since later on the phase shift is going to be so subtle, very hard to see if I don't do it, accurately. So I'm going to get a point here. Okay, I'm going to go down, get to the minimum, come back up, and reach the maximum. Okay. But what if I claim that this is the graph not for cosine, for cosine 2x, yeah, just cosine 2x. How should I label the horizontal scale? Cosine 2x. It goes from 0 to pi, right? Because it has been squeezed by 2 times, right? So now, if you want, just show me one more point, which will be, the midpoint, right? Pi over 2. That should be good enough, right? Don't even bother with the quarter points. But now what about the phase shift? It is to the right, but by how many units? All right, so the phase shift is, if you remember C over B, right? If you want like a fact out of 2, so anyway, you'll see that it's pi over 8, right? You guys see that? To the right. All right, so that means I'm going to be shifting the graph to the right by pi over 8. And this is why I still want to label this guy as pi over 4, right? And I'll take another half. This is pi over 8. Okay, so now I need to get a graph. Instead of starting from, somewhere on the y-axis, I'm going to start from here, right? So I'm pushing everything to the right. And it's going to come down. It's supposed to hit pi over 4, right? But now everything is shifted to the right by pi over 8, which is just a little mark. So it'll go like this, right? And it's going to go down, right? And hitting the minimal a little bit later, right? Come back up, right? And it'll be reaching back up to the maximal, again, at a later point. But how much you think that label has to be? When I come back up and hit the maximum again, not at pi, because everything has been shifted to the right by a little bit, right? How much should I label at this point? How much has the graph been shifted to the right? That means every point is shifted to the right by pi over 8, right? Therefore, this is nothing but 9 pi over 8. You're just adding pi over 8 to the pi, right? So now if you do that, if it's for Q, I see right away, oh, you have shifted it, right, by exactly the amount I want. Okay? So the green curve is, let me complete this. Okay, so green curve is come on, cosine of 2 pi minus pi over 4. Okay, and it's going to come down. You'll see why I have to show that it come across the x at this point. So now, how do we get the secant? For secant and cosecant graph, you need to show me where the VAs are. Now the VAs of secant or cosecant will occur at the x-intercepts of their reference functions. So the reason is kind of simple. If you think about cosine, when it comes across the x-axis, cosine needs to be 0, right? That's where, it comes across with the x-axis. Right? So cosine can be 0 here, here, and there. But secant is the reciprocal of cosine. if cosine happens, is 0, how much is secant? 1 over 0, right? How much is 1 over 0? It's either positive infinity, right, or negative infinity. And that's why just go ahead and find the x-intercepts of the reference function, and they will be the VAs. I have a VA here and here. One more here. Now, once you find the VA, in between two VA, locate the maximum or minimum. So I find this maximum, right, of the cosine. Now just go ahead and flip up the graph, make it like a U shape, so that you see that the graph's gonna blow up, right, when it get close to, the VAs. So this is like you're looking at a U shape down, right? You take the VA, or you take the maximum and flip the U shape up, right, to get you part of the secant graph, and find the minimum, flip it down, right? That's all. But there's something what hasn't done, right? The vertical shift. Well, you just have to push the graph up by 2 units. But is that good enough for you to pick an option if you don't have to graph it by hand? All right, so now definitely not A, right? You see that this graph has been pushed down, right? So let's see. Well, it's hard to tell whether it's going to be. Let's scroll down a little bit. Oh, you know what? Definitely not D, since there's no vertical shift, right? See that? So it's either going to be C or is it somewhere at? Okay, that looks. Oh, that's hard to tell. Yeah, because the VA. Now, what about a VA? So I have a VA at somewhere between pi over 4 and pi over 2, right? Oh yeah, I think that there's a VA somewhere here, right? So that's kind of subtle. So that's why I said that I have to show you exactly where the graph's supposed to be after I shift it by pi over 8, pi over 8 to see where the graph has to be located. So this one, you have a VA at so that's a wait, that looks. Oh no, I think that this is too wide because the VA a little bit to the left of the y-axis and also somewhere between the pi over 4 and pi over 2 will get you one of the U shape, right? But this is not the correct location for the VA. Right? Anyway, so you're looking at the C, but hopefully you'll be taking probably a special value if you have to figure it out only between B and C, right? Maybe take, let me see if that's gonna work out. If I take it as, well, not gonna be the y-intercept, doesn't help at all. Maybe pi over 2. Yeah, I think that the pi over 2 is probably gonna work out better. If you put pi over 2 right into the calculator, evaluate it. If B is correct, it's supposed to return something like 3, right? Or at least it's positive 3, right? Now, if you do pi over 2 in letter C, it will return something small, right? But if it's hand graph, then there's a lot for you to show me, right? The reference graph is pretty much like if you get a secant graph or a cosecant graph, you're probably gonna get 3 points for graphing the reference function, right? 2 more points one for, if I were to grade it, one for the VA, right? The other for the shape of, the secant and cosecant graph. Okay.